I'm going to do an example from section 3.1, part B. So this is a Lumen example, and it says we have a function p of x is 30 times e to the negative 0.08x, and then it tells us that x is the number of units sold, and p of x is the customer price per unit in dollars. And then it wants us to find the revenue function. And again, it's telling us inside the input to the revenue function is also x, the number of units sold. And it wants us to find r prime of x, okay? And r of x is the revenue function, so I input the number of items sold, and I'm going to get an output of revenue. This here is my marginal revenue, or my derivative function of the revenue function. And so we know that when we're talking about revenue, revenue is equal to price per item times the quantity of items sold. And so we're just going to scan through the problem here. We see that we're using x to represent the number of units sold, and price is this whole function. This whole function is price. So we know then we can write the revenue function, r of x, as p of x, which is our price function, times x. That represents our quantity, or the number of units sold. Now let's just go ahead and plug in each formula. So we know that p of x is 30 times e to the negative 0.08x, and x is the quantity of items sold. So now we need to take the derivative of the revenue function. The derivative of the revenue function. So when I look at this function here, I see that I have a function, the price function, that's my first function, times quantity, second function. So we have a product rule. The other thing that I notice is this exponent here tells me I have a chain rule. I have a function, e raised to another function, negative 0.08x. So if I have a product rule, the product rule says I take the derivative of the first times the second function plus the first function times the derivative of the second. So the derivative of that first function is just 30e to the negative 0.08x times the derivative of negative 0.08x, which is just negative 0.08. Then I'm just going to rewrite the second function, which is just x, plus, right, I'm just following this format here, plus the first function. So I just take that first function and I rewrite it, times the derivative of the second. Well, the derivative of x is just 1. So I'm going to do this by hand first, and then I'll open up Excel. So part of this question wanted us to find the max or min of this function. And so we just found the derivative of the function, r prime of x. But if we want to find a max or min, we're going to need to find all the critical points of r prime of x. So we're always going to want to try to simplify this if we can. And I see here actually that I have a 30 e to the negative 0.08x, and over here 30e to the negative 0.08x. So I can factor that out. I can factor out that 30e to the negative 0.08x, and when I do that, I'm left with negative 0.08x here plus 1. So to find the critical points of a function are either where the function is equal to 0 or undefined. So because I'm dealing with my revenue function, or my marginal revenue is the function is the derivative of revenue, I either want to find points where it's equal to 0 or it's undefined. So when I look at my marginal revenue function here, I have, right, these two functions. This is an exponential function, and this is a linear function. Okay, and if I want to set it equal to 0, if I want to set that equal to 0 to find the critical points, then I just do that here. And I know that using the zero product property, right? If this term is equal to 0, or if this term is equal to 0, it makes the whole thing 0 because 0 times anything is equal to 0. So let's take a look at the first term. Let's take a look at this first term here. So if I set 30e to the negative 0.08x equal to 0, well, this is an exponential function. If you recall, an exponential function is in the form a e to the rx. And so a represents my y-intercept, so right here, 0, 30. And because r is negative 0.08, I have a decreasing exponential function. Because I haven't shifted it up or down, I know that I'm going to have a horizontal asymptote at y equals 0 on the right-hand side because it's a decay function. So because of that, I can't make this function ever equal 0 because it's a decreasing exponential. So I can't force that to equal to 0. So there's no critical point that comes out of this first term. If I take the second term right here and I set it equal to 0, negative 0.08x plus 1 equals 0. Now I can isolate, or I can solve for x. That's my critical point. I can do that algebraically. And when I do that, I could add 0.08x to both sides. And that would give me 1 equals 0.08x. Then I could divide by 0.08 both sides. All right. And that is going to give me either negative 1 over negative 0.08 or 1 divided by 0.08. And when I do that division, I get x equals 12.5. That is our only critical point. So let's go to and do this by hand first. So once I get my critical point or points, I'm going to set up my number line here. Now remember, when I look at this function, okay, I know that my domain is going to be all real numbers because I have this exponential function times a linear function. So my domain of this function is all real numbers. So this actually is kind of going from negative to positive infinity here. Anyway, so we're going to divide up our domain into subintervals. And I'm going to start right here at my critical point. I know that at x equals 12.5, my marginal revenue is equal to 0, or r prime of 12.5 equals 0. We just solved for that. That means that if I take my revenue function, it means that the function is flat at that point because the derivative is 0. So now I want to determine, do I have a max or min or neither here? So what I need to do now is I need to take some test points. I want to take a point where x is less than 12.5. So a lot of times I'll just use an easy test point, 0, 10, negative 1, 1. In this case, I'm going to use x equals 0. That's less than 12.5. And I want to check and see what's happening on either side of 12.5. So when I plug that 0 into my derivative function, r prime of 0, I just put 0 in everywhere there was an x, and I get positive 30. Positive 30. So because my derivative is positive, it means that my revenue function at x equals 0 is increasing. Okay? Increasing, flat, and then I want to take a test point of x greater than 12.5. So I just picked x equals 20. I'm going to input 20 into my derivative or my marginal revenue function, R prime of 20. I put in 20 everywhere there is an X, and I get negative 3.634. Because my marginal revenue or my derivative is negative, that's telling me that my revenue function at X equals 20 is decreasing. That's what this negative sign is here. So I know that I go from increasing, flat at my critical point, X equals 12.5, and then decreasing. This is telling me that I have a maximum. I have maximum revenue when X equals 12.5. Here's what I'm looking for in terms of describing. Because R prime of X changes from positive to negative at my critical point, 12.5, that's telling me that my revenue function goes from increasing to decreasing. That's my definition of a maximum. The point where a function changes between increasing to decreasing tells me that I have a maximum. So my revenue function has a maximum at X equals 12.5 units sold. So we can't forget what these variables mean. If I go back to my problem, I know that X represents the number of units sold. So that means when I sell 12.5 units, I'm going to maximize my revenue. If I want to find out what that revenue value is, I need to plug it into the revenue function. Remember, revenue function says when I input units sold, I get an output of revenue. So I'm going to plug in 12.5 units sold into my revenue function, and I get that the maximum revenue is $137.95. Now, because I was also given a function for price, P of X right here, I can also find what price I would be selling these things at. So if I put in 12.5 units, that's my X equals 12.5, into my price function, this is my price function, I know that the price that will maximize revenue is $11.04. So if I come to my Excel file, I have this all set up here, and what I've done is I'm going to put in all of my functions. So I'm going to put in my X as my input, then I'm going to have my price function, then I'm going to have my revenue function, then I'm going to have my marginal revenue function. And so if I do that here, oops. Okay. So here is the proper spreadsheet. So I'm not going to, I can't have negative units sold. So I'm going to start at 0 units sold. And then I'm just going to, I don't know, I'm going to go up to 20. I can always change that if I don't get a good view of my function. I'm going to put my price function in. Price is 30 times e to the negative 0.08 raised to the number of units sold. That's my price function from right up here. My revenue function is just, I can just use cell referencing when I'm in Excel, right? I wrote the function here. It's the price function times the quantity function. So quantity times price, that's my revenue function. I use cell referencing. And then my marginal revenue function, I just put in my derivative function that I calculated by hand. And that came from right here. Okay, I can enter it either way. Doesn't matter. I typically would try to enter it in the simplest form or most simplified form. All right. So now I copied all of my formulas down, and I can see as I increase units sold, I can see that my price function is actually decreasing. Here's my revenue function. My revenue function is increasing for a bit, increasing. Now it starts decreasing, right? And I want to find out how many units do I need to sell so that I can maximize revenue. So I took my derivative function here and I copied that all the way down. So let's interpret this. Okay, here's my derivative function, or my marginal revenue function. And so these values are positive. Remember, when my derivative function is positive, that's telling me that the function I started with, or my revenue function, is increasing. So these are slopes. Because these slopes are positive, it means that my revenue function is increasing. Revenue is increasing, 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 increasing. Okay, they're all positive. Then I get to this point at 12 units sold, somewhere between 12 and 13 units sold. Notice that my function changes from increasing to decreasing, right? A negative derivative tells me that now my revenue function is decreasing. So I want to find the exact point where it changes. Remember, the exact point where it changes is my max or my min, or neither. But here I can see it went from increasing to decreasing. So I know that I'm going to have a maximum there. I'm going to use solver. I'm going to pick the point that's closest to 0, and I'm going to do data solver. All right, I want to force that cell to be equal to a value of 0, and I want to put the answer in. I want to find out how many items do I need to sell, and I'm going to solve. Okay, and if I want to, I can round that, so I can see this is just scientific notation here. That negative 2.68149 to the negative 7, that just is 10 to the negative 7th power, which is a really, really small number. And I can see here, when I sell 12.5 items at a price of $11.04, I'm going to maximize my revenue to 137.95, and I have found my maximum here.